Howdy, I'm going to walk y'all through OpenRocket, how good practices, what you need to know when you're getting into it and building a rocket, and here for modeling. So when you get in, it's completely empty, you don't have a rocket. Um, you're likely already going to have a model from other people that you're going to be building on. It's very rare that you just start over. There's a lot of iteration, more so iteration than building over again. But we can start a new one. You can have nose cones. So I'm just going to start from the top down. We're going to build a rocket here with commercial parts, because a lot of these already have commercial parts in the software. So I know that I'm going to be using a Mad Cow rocketry that's 5.5 inches in diameter. I think it's this one. Let me see. Sure, we can use this one. Ooh. Okay, and then now you want to add your next set of tubes. So I know that the fiberglass goes into this nose cone, so now we're going to have a body tube. And it lists what's already compatible with that piece of hardware. So here I know we have Mad Cow fiberglass here, so I'm going to select that. You can change the length to whatever you want, of course. Going over this page in general, because this happens whether you have a commercial product or a custom product, you're going to have your general, which is going to be like length and dimensions. And then you can have it as a motor mount. We'll get to motors in a second. You can override the mass and center of gravity of this thing. Appearance and comment, not important. But then finish is something that is hard to know what to put, but will affect your altitude. So of course, if you're mirror surface, you're going to have a lot less drag. Okay, so we're going to go with that. Another thing, a lot of times we're going to have a body transition, and it's really just necessary for the software, because really our body tube carries the transition with it, with the bulkhead. But we're going to just add a transition here. I'm going to mass override this to be 0 pounds, because I'm going to add the mass of the bulkhead itself of our tank to have the mass. And so this is just going to be 0 pounds. But our fore diameter has to match, but our aft diameter should be bigger, because I know the outside of my rocket is 6 inches. So it gets bigger, and I think in the CAD right now it's only 1 inch. That's how long the transition is. And because it's mass overrided, it doesn't matter what it's made of. It doesn't matter at all. Okay, now I'm going to add a body tube. This is going to be our custom aluminum body tube, which is also our tank. So we're going to say it's made of aluminum. We're going to say it's 138 inches, which is how long it is. Inner diameter is 5.75 inches. Just kidding, it's 5.5 inches. And this is a motor mount. So we don't have an engine in here yet, but we will. Okay, so I'm going to keep going. I know that after this thing, we're going to have another body tube, and that's going to be carbon fiber. And so I'm just going to do carbon fiber. We're overwrapping the back end with carbon fiber. We're going to say it's all the same dimensions and everything, but of course you need to change it for what it's going to be with you. I think it's going to be like that long, about. There's going to be internal things that you need to add. So I know back here we're going to have an engine block. This is going to be our steel retaining ring, and it's custom, so you got to make sure you go in here, steel. Overall length, you treat it as a perfect cylinder. So I think it's like about that long. Set your outer and inner diameter how it's supposed to be. Okay. And now, let's get to fins. So you have to select which part you want the fins on. I want it on the carbon fiber. We're going to add trapezoidal fins and make them to where they look right for now. There's plenty of research you can do into how fins are supposed to look, but we're not going into that. So let's get something that looks pretty cool. Make sure we only have 3 fins. I want it perpendicular in the back like that. Yeah, whatever, we're close enough. Okay, whatever. We'll go with that. Component materials, it's going to be, so remember, it is going to be carbon fiber, but the majority of the material is a foam to give it thickness. So it's going to be foam. And then fin cross section. It's likely just going to be rounded, unless you're going to 3D print a aerofoil on your whole thing, and you're going to grind down the thickness on the back end to be an aerofoil. So it's just going to be rounded because you're going to 3D print a leading edge on this. Okay. When it comes to the motor itself, this is where it gets a little bit complicated because you need to tie in all of your propulsion knowledge. So we're going to go to our propulsion model. This is our current Excel sheet for Half Cat Rocketry. We're using their calculator for now until we make our own. So this thrust curve is the main output of that thing. Over here on the right, it spits out time and thrust in newtons, I believe. So you're going to highlight all that. You're going to copy that, and you're going to paste it somewhere. Now, where do you paste it? So you go to Edit, Preferences. This place is where they store the thrust curves. So we're going to go there. Now I already have one in here, so I'm going to click on that and see what it looks like. And let's go over the format of this file. So you have the name of the engine. You need to change this for every configuration of the motor that you do. Anytime you update the thrust curve, let's get a new name so that we know what we're talking about. Then you have the diameter of the motor. For us, we're doing a liquid. So what we're going to do is set the inner diameter to be the inner diameter of the tank. So that's 5.5 inches, but it's in millimeters. And then you're going to have the length. I just put it that it's going to be the length of the aluminum tank that we have. For this one, 0, it is going to be a charge delay. We're not having any charge delays because we're doing our own recovery, so we're not doing that. And then this is going to be the mass with the mass with propellant, and this is going to be the total mass. And so what we're doing is we're just saying that the mass here is just the mass of the liquid, nothing else. And that's the simplest way I can think to do it. So that's both going to be just the liquid mass. And then you have a manufacturer after that. Don't put a 0 as your first number here. Just go ahead and start with your first time value, and then copy and paste that all the way down. Save it. Make sure it's a .eng file. So when you're saving this, it's going to probably want to save as a text file. But go to All Files and make sure it's a .eng file, and you'll be good. So then you'll have to restart the program every time you change your thrust curve. So now I want to put a motor in here. So you go to Motors and Configurations. It's selected the body tube. New configuration. The name of that motor was Elysium. So I'm going to select that. And you'll notice it fills here. Well, the limitation of this is that it assumes the center of gravity of your motor is at the center of your length. And that's probably not true. So the best thing I can think to do right now is have the motor length and position be where you calculate your center of gravity to be. There's more math that you can do to figure this out. But yeah, now we have our motor in here, and we can just go ahead and launch the thing, I think. So we're going to go to Flight Simulations, and we're going to run it, and we're going to see what happens. So as you can see, I have no weight in here. It's very light, so we're going pretty high, we're going very fast, and we have super high Gs. Important information that's on this page: we have mass with no motor, mass with the motor. So, and you have your length, max diameter. Over here you have your stability margin. So that is going to be your center of gravity as it relates to its center of pressure. If you have a stability of 1, that means your center of gravity is ahead of your center of pressure by 1 diameter length. So our diameter is 6 inches. So if we had a stability of 1, we would have a length of 6 inches between your center of gravity and your center of pressure. You want that to be above 1. And it doesn't do it here, but stability you can look at over time because your center of gravity shifts as you're losing mass. So you got to look at it over time and see if you remain stable over time. So another thing that you need to watch out for is recovery. So where do you want your recovery? We're probably going to have it in our forebody right here. So you can add something like a parachute. Boom. I'm going to say this is 12 feet. This is our main parachute, and it's 12 feet in diameter. 0.8. This is going to be based on whatever manufacturer you have. And I'll put the position somewhere back here. When you are deploying the parachute, so you have settings here where it says, I want to deploy at the first ejection of the stage. I don't want to do that. I want to deploy at apogee. So then you press OK. But as you'll notice, there's this cross right here where it says this parameter can be overridden at each flight configuration. So you have to go to flight configuration, and then where it says recovery, select it, and then you have to make sure your parachute actually deploys at apogee. So when you add another parachute, because I want a drogue chute, let's say, so this is a streamer, so I'll make it really long. And this one I actually want an apogee. But when I look at our parachute, now I'm going to want this at a specific altitude during descent. Let's say it's 1,000 feet above the ground, we deploy it. Okay, but now I go to configurations, and I have to go to here, and I have to change it as well. So my streamer, I do want at apogee, but my parachute, I want at a specific altitude, which is going to be 1,000 feet. Okay. So that's everything I think you need to know about OpenRocket. It's very useful to have a spreadsheet of all the actual masses of your components. Make sure that everything is accounted for, because when you build it and you're 5 inches off on your center of gravity, they're going to be looking at you to figure out why. So that's what I can say. Make sure to save it. Nothing saves automatically. That's all I got for you.